What are some of the global threats to biodiversity? First, I want to emphasize that virtually everything we do locally has global consequences. When we talk about something like a greenhouse gas or a pollutant, that's something we produce locally from our car or from other things that make up so many of our day-to-day human activities. But in the grand scale of things, even these local activities and impacts can have global effects. Greenhouse gases aren't just carbon dioxide, they also include water vapor, methane, ozone, and nitrous oxide. But for this tutorial, we want to focus on the major effects of carbon dioxide, which chemists refer to as CO2. Increases in the amount of carbon dioxide in the atmosphere mostly come through the burning of fossil fuels. Fossil fuels contain huge amounts of carbon, and when they're burned, they not only release heat energy, but they also release carbon dioxide. Although it's the energy, the heat that we want, carbon dioxide is a side product of the burning. That's why atmospheric CO2 is increasing. Why are so many people concerned about that in terms of global change? The answer means we need to say a few words about the greenhouse effect and how that actually works. Light rays from the sun arrive in our atmosphere as shorter wavelength radiation. This light energy hits the surface of the Earth. Some of it is reflected back in the form of slightly longer wavelength radiation, and it's this longer wavelength radiation that falls into what is known as the infrared area of the spectrum. Infrared is the same as heat, basically. So when light hits the surface of the Earth, it's changed into heat energy. That heat energy is, to a certain extent, absorbed and some of it's reflected back up into space. But greenhouse gases actually have a kind of snacking preference for longer wave radiation like infrared energy. This keeps the heat energy close to the Earth's surface instead of allowing it to go out into space. The more greenhouse gas you have, the more the heat builds up. It's no coincidence that this is called the greenhouse effect. It works almost exactly like a gardener's greenhouse. A greenhouse is made of panes of glass, and all that nice sunlight goes through the glass. It strikes the plants, the soil, the stuff inside the greenhouse. But much of it becomes infrared light, or heat, held within your greenhouse and bouncing around through the air inside to make things nice and warm. To a certain extent, like our little plants in the greenhouse, Earth's organisms benefit from the greenhouse effect. Life on Earth would probably be quite different or perhaps not exist at all if we didn't have some greenhouse effect. The problem is that now we've increased the rate at which greenhouse gases are being introduced to the atmosphere, and therefore the rate at which warming occurs. Even gardeners have to regulate the flow of light into a greenhouse to keep it from overheating and cooking their veggies before they even get picked off the plant. So there's your problem. Rate. It's not so much that CO2 buildup is happening, it's happened before in the history of the Earth. Scientists even see cycles to these things. But it's the current rate at which CO2 content is changing that's the running theme behind all of the problems that we're seeing today. Life just can't keep up. Here's a graph that demonstrates CO2 content in our atmosphere over time. What I like about this particular one is we go from about 400,000 years ago to the present. We've got these 100,000-year intervals and a series of interesting drops and peaks and drops and peaks. And then coming to the present, it kind of goes off the charts so much that we've got to magnify that part of the graph to see it better. In here, in the industrial age, we're experiencing this greatly enhanced period of carbon dioxide production through the activities of humans. There are agencies out there that are very concerned with this problem. One of them is the Intergovernmental Panel on Climate Change, or IPCC. According to the most conservative IPCC estimates, the global temperature on Earth, and this is an average temperature over the whole planet, by the way, is going to rise 1.1 to 2.9 degrees Celsius during this century. That's 2 to 5.2 degrees Fahrenheit. Modeling or estimating what will happen is tricky, which is why we have these suggested ranges instead of precise single figures. But what we can say is that in the worst-case scenario models, we're talking 2.4 to over 6 degrees Celsius, and that's a whopping 4.3 to 11.5 degrees Fahrenheit. Imagine the repercussions. If I think about going to my thermostat and just suddenly overnight dialing it up 10 degrees, not only are my electric and gas bills going to go through the roof, but it gets beyond cozy when it's over 80 degrees in my house. It's not really my optimum temperature. For one thing, the ice in my drink's going to melt a heck of a lot faster, which is, equally unfortunately, one of the major problems for the Earth as well. We're talking, of course, about global sea level rise. It's really the continental ice masses that should be giving us the greatest cause for concern. It's fairly simple. Melting of ice on places like Greenland and high mountains, for example, will result in more water going into the ocean. The frozen elephant in the room is Antarctica, because almost all of the ice there is on the continent, which means that when it melts, it will add enormously to the amount of water in the ocean. Even partial melting of Greenland and Antarctica together could result in 4 to 6 meters, or about 13 to 20 feet, more water in the ocean worldwide. But it could take several hundred years for that. People are looking at this very, very carefully, because if you think about 20 feet, that's enough that entire countries like the Maldives, which exist largely as low-lying atolls in the Indian Ocean, would disappear underwater. Almost any low-lying area, the Netherlands, aka Holland, for example, or New Orleans, would face serious additional flooding threats, and then you add to that things like hurricane and typhoon storm surges, and it's an enormous problem. What does this mean for biodiversity, though? Well, in the first place, you're going to lose these low-lying places, and therefore their habitats and the species living in them. Some of these habitats are home to rare and endangered species. Apart from the actual change in sea level, what really is a major problem for biodiversity is the warming itself. Again, remember that every species has its own optimal habitat and tolerance ranges, and that includes all the things that go along with living in the right temperature regime. The IPCC estimates that a 4 degrees Celsius increase, just over 7 degrees Fahrenheit, is going to result in major extinction due to the inability of organisms to adapt to the changes. It's this rate thing again. Organisms can't move to cooler areas fast enough or adapt fast enough. Sure, some migratory animals can change their patterns of migration a bit, but what about the organisms that can't change? What about the ones that can't move? Entire forests come to mind. Think of mountain ranges. Forests will move further up the mountainsides, completely altering or displacing entire ecosystems as they go. And we've got really interesting examples from some of our own investigators here at the Academy, people like Dave Cavanaugh, who studies endemic beetles specialized to live in the icy areas high on mountains. These colder places are disappearing. The beetles are moving to higher and higher elevations, but pretty soon they're going to run out of mountain. Even marine ecosystems are not immune. A 2 degrees Celsius increase in the ocean, about 3.5 degrees Fahrenheit, doesn't sound like that much, but it's a lot because we're talking about a huge amount of extra heat over the entire huge size of the ocean. And we've been talking about an average number. Some places are going to be warmer than that. Some are going to be cooler, but an overall 2 degrees Celsius increase is enough to result in major coral reef die-offs. Reefs just can't respond to these rapid temperature changes fast enough, nor move to other places, even assuming that other suitable habitat was available. Those are some of the effects of global warming, but we also need to talk about the chemistry of adding CO2 to the world's ecosystem. There's some early evidence that shows all the regions of the world are going to be affected one way or another just by this simple addition of CO2, even if you don't talk about the global warming consequences. Studies indicate that plant life tends to react to an increase in CO2 by building more of themselves through that amazing process of photosynthesis. The amount of carbon dioxide that plants use and turn into organic molecules for their own use is what we're talking about in fancy terminology like sequestration and carbon fixation. It's just plants saying, "Oh, hey, there's more carbon dioxide. I can make more of myself." That sounds on the face of it like a good thing. How bad could more plants actually be? In fact, sequestration and fixation are likely reasons that we haven't already had truly runaway global warming. But there's a limit. There's an upper level to how much plants can collect, use, or sequester carbon and thereby reduce surrounding carbon dioxide levels. That's because CO2 is not usually the chemical that runs out first as plants build more of themselves. It's kind of like saying, well, you know, I could put lots and lots of oil in my car and it seems to be running fine, without remembering to add some gas every now and then. You're going to run out of gas and your car eventually stops, even though you have lots of oil. Biodiversity in that sense could actually decrease as the carbon dioxide levels increase because you've got unequal abilities among plant species to sequester or absorb all this new carbon dioxide. As that happens, biodiversity, or species richness, can drop because plants more sensitive to the limitations of other necessary chemicals will die. Forests, marine phytoplankton, and their surrounding ecosystems become less functional as species die off, and therefore less effective in sequestering carbon dioxide, causing a kind of feedback loop in which global climate change actually gets worse and worse as the unused CO2 builds up. Think of that next time you hear a car go by. Even something that local can go global in a way that has huge effects really worth thinking about.